Good morning, guys. And today we'll cover the rest of this part, that is feed forward control action. Okay, so uh, again, that is and in previous classes you have seen what is the difference between feed forward and feedback. Okay, so let's draw this option. This is our objective part. Okay, guys, uh, you can see, just realize this thing first. In feedback control action or feedback control system, you can see the output variable is measured. Means the temperature of this output, if this is a temperature controlling process, or the flow, any variable which is directly taken from the output. Okay, then it is observed, and as per this requirement, in feedback control system, the input will be controlled. Okay, but in a feed forward control, in this feed forward control, we have no idea about the output. This output, if this is a 100-degree temperature is required, we don't know what is the temperature is now at this present moment of this output. We just measure we just measure the disturbance, and this is the feed forward control action. Means we are feeding our input as per our forward, as per our forward action. Means forward action means this is the disturbance will come, and then as per our experience, as per our rules base, we are doing the control of the input. So this is the main difference between the feed forward and the feedback control action. Why we are so many times giving this feedback control action? Because we all know this type of control action everywhere, but rare time we are applying this uh, feed forward control action. Okay, because whenever we are just we are driving, just like you're driving, you can see, or anything. So a driver is watching, and say this is front page. Okay, steering over there, and if there is a turning, then driver can see there is a turning, then it will just move it. If he or she will not able to see the at the front, then it will going to cross over this road, and it may be go outside of this road. So it causes an accident, or it is not wanted. So this type of action is called closed loop control. But why this is closed loop control? Here is no sensor is applied directly, because actually controller is driver. So if we think that is driver is a controller, then we can observe these things. Yes, here this man or this operator, actually he or she is a controller. Okay, just like a driver. Here is also controller, but we are drawing this picture. Why? Because so that we can understand the process easily. Now it is the point of evaluation where we apply this feedback control system, where we apply the feed forward control system. Look, whenever your disturbance is less or something, your process, where we know the time and we know the process value, then we are calculating this set point value and the process value deviation, and then we are also applying this input channel. But there is no presence of disturbance. Disturbance in the means maybe your output will be uh, variable. Sorry, your input may be variable. Your process may be variable. So this type of disturbance will occur. Then this feedback control system never reach the set point value, or its accuracy is very less. But in feed forward control system, we are applying our input as per our demand, as per our disturbance. Disturbance means which is not expected. Okay, so we are going for an example, then we can understand. Say in this is your process, this is your process, this is your comparator, and this is on off valve. Here is on off valve or switch. Okay, so total these things is called controller. Okay, this is called controller, and this is your process, this is your output. Now, and this is your feedback. Okay, so say this is your process. In these vessels there is a what temperature is maintained. Say a 100-degree centigrade is maintained. So you know the content of this process is water or any liquid. But this is the fixed. Say this is the 100 liter of water is content over here, and you are applying some steam flow. Okay, so in feedback control system, it is always comparing, it is always measuring first. That is what is the process temperature. This is your sensor. This is sensor means this is the maybe TC. After a few days you can understand what is TC, what is RTD, etc. This is the temperature sensor. It will sense that is 80 degrees centigrade, then it will say to the comparator that is our deviation is till now there is a deviation 100 to 80 degrees. So till there is a deviation of 20 degrees centigrade, then it is allowing the steam flow, allowing the steam flow. Again, after few seconds, again it is continuous processing. Okay, then it is applying this sensor, and it is measured that is 90 degrees centigrade. So there is again 10-degree deviation. So it will allow some flow of steam. After a few seconds, again it is measuring that is yes, this is 100 degrees centigrade. Then at that moment it will say low. There is no deviation, that is 0 degree centigrade. At that moment it will stop this steam flow. So this is the closed loop path control action. In this way, it will control the temperature or maintain this temperature. After few seconds, if it is decreased, say this is temperature decrease up to 99, means 1 degree centigrade, again it allow flow to this chamber, so that it maintains this 100 degrees centigrade. In this way continuous process is going on, but nowhere you can find the another 100 liter or another 50 liter water will be added. Then what happens? If it is happened, if it is going out, then what happens? It never reach to the set point value quickly. Okay, and maybe it will never reach to the set point value because disturbance is coming. Sometimes 100 liter is coming, sometimes 50 liter is coming. So it will never reach the 100 degree centigrade anymore. Okay, because all time disturbance is coming. But in case of your feed forward control action, say this is your process. This is full of water. We filled it with some water. Its temperature we want to maintain 100 degrees centigrade. Okay, temperature, that is the set point value, set point. And now we don't apply any feedback control action. Okay, but we have the rule base. This is the rule or the experience base rule. Say this rule, what are they saying? If 100 liter water is there, we need the temperature of 100 degrees centigrade. That is quantity, that is temperature, means process value, and that is time. Say we are applying for the time, and it needs say 10 second. Okay, then steam flow, this is our steam flow. This is manipulated variable or input. Okay, this steam flow should be will be 10 second. Okay, and now what happens? Disturbance is coming after 9 seconds. You can see there is another disturbance is coming. That is another 50 liter of water. 50 liter of water is added, which temperature is 20 degrees centigrade. Say at the 9 second, after 9 second, its temperature reached say 90 degrees centigrade. Okay, look, 90 degrees centigrade. But now you can see after 9 seconds, just it will reach to the set point value. But after 9 seconds, another 50 liter water is added. So total water is 150 liter. So temperature suddenly decrease, say 70 degrees centigrade. Temperature decrease suddenly 70 degrees centigrade. But what happens if there is a feedback control system? Then it will again applying steam flow until and unless it will reach the 100 degree centigrade. But here is the feed forward control action. We know the from the rule base or the experience. It is called, as per our academic language, we call it that is experience. And for your technical language, you can find everywhere there is some rule base. There is a chart or the rule base. If 150 liter is there, we need here is another chart, 100 degree centigrade. Then we have to flow say 15 second steam flow. So operator will allow it up to 15 second. Again after 15 second it will reach your 100 degree centigrade, because this experience was made by your uh, vigorous experiment. Okay, they have seen that if the same liquid is there, if the base temperature is 20 degree to 20 degree, if the 150 liter is there, if base temperature is 20 degree, then it will reach to the 100 degree centigrade for the 15-second time. Okay, so in this way, this we are measuring the disturbance, means how much liter, how much disturbance is coming with this. Okay, so this way feed forward control system is applied. So here what is the advantage of this feed forward control system? Look, you have the only rule base or your experience. So we are applying on this. So, so we no need of feedback system. So if there is a sensor, there is continuous processing is going on. But if we apply just like your timer for your say bread toaster, you are applying some timer system. Okay, so we are just doing it. After some times we need we will get our required temperature or required process value. By this applying, we are not applying so many hi-fi your technology, because only your rule-based normal technology technician can apply this. And but in this case, you know, this process control, this is a closed loop process control. Okay, but closed loop process control, here is a the microcontroller based controller, or here is a sensor is there. If there is a problem of sensor, if say this is 100 degree centigrade, but your sensor measure is 90 degree centigrade, so your process never get the process value accurately. Okay, but here only your experience is working. So if we go for an example, then we can see the just like previous example, that is your bread toaster. So many times you can get this type of open loop control system. Actually it is given for open loop control system, but this is depends on your or feed forward control system. Say your bread toaster, you are applying 100 degree centigrade for your bread, 100 degree centigrade for 5 seconds. After the result, you can see your bread became burned. Okay, so next time you are applying 100 degree centigrade and apply for the 3 seconds, you can see your bread became just raw. Okay, then what you will do, you will do just 100 degree centigrade and apply for the 4 second. You can see your bread is perfectly toast. So what happens? This is your day one. Day one. So next day, what will you do? Day two. Day two, you will do just apply this best option. This is called best option. So you are applying 100 degree centigrade for the 4 second, and you can get perfect value. So this type of rule based, this type of experience is working over this feed forward control system. So where the disturbance is varying, disturbance is coming all time, then we are applying this type of feed forward control system. Okay, guys, I think you can understand this thing. If you have any question, then you may ask me. Then I am going for the some features of the feed forward control system. Okay, now you can write down some features of this uh, feed forward control system. Conventional feed, sorry, conventional, sorry, loop can never achieve perfect perfect control. But where it is, if conventional feedback control loop can never achieve perfect control, but conditions is that where disturbance means is coming. Okay, if there is no disturbance, feedback control system is okay. But if there is a disturbance, feedback control system can never achieve this perfect control. Okay, so the disturbance occurred and changes the set point. Okay, so where disturbance is not coming, then it will not achieve. So this is the point. And in respect to this feed forward control, you can see a feed forward control. Feed forward control measure disturbance directly and takes control action to eliminate its impact on the process output. Okay, so you can find there is some difference between the feedback control system and feed forward control system. In feedback control system, there it is measuring the output, and it is measuring the disturbance. Okay, so it has no idea. Second point, it has no idea about disturbance. It has no idea, but in feedback control, feed forward control system, no idea about about process output. Process output. So maybe your temperature not reach up to the 100 degree centigrade, but it is okay for this case. But in this case, if temperature is not, or the process value and set point value is not same, then it is giving the error. But here it is no error is coming to here. So this is the main difference. Okay, and for the feed forward control action, you can see for your feed forward control action, information is the play the vital role, because if you have no idea, no information or no rule base, then you can't apply this feed forward control system. Concerning more conditions might disturb the control variable is converted converted into corrective action to minimize deviation of controlled variable. So in feed forward control action, information should be perfect. Otherwise, it may causes the deviation of your process value and your set point value. Now, next point is that look, feed forward controller have the theoretical potential for perfect control, because practically whenever we go for the closed loop control action, whenever we go for this closed loop control action, and it will measure the feedback, it will measure the process value. So if it is still it is performing its control action till it is set point value and process value should be same. But in your feed forward control action, you don't know what about the process value, what about the output value. So theoretically it is potential, because we know the rule, apply the rule base. If 100 liter is required, so 100 degree centigrade, 100 liter, 100 degree centigrade, then 10 seconds. So theoretically we can apply, but we don't know about the process value. Okay, we know the set point value. Set point value is 100 degrees centigrade, but we don't know the process value. So this is theoretically potential, but practically it may not be potential. Okay, so this is the few features of your feed forward control action. Okay, now we have to draw. So guys, what is the feed forward control? Is it a open loop control action, or is it a closed loop control action? I think you can you can understand this thing. Then what is the uh, you can tell me what is the actual it is a closed loop control action or a open loop control action. After till now you have I think you can understand this thing. Then tell me. This is your question. This is my question.
Sir, please show the top part.
Top part here is the top part, but in your previous part was just deleted. Uh, just apply your concept. Is this a open loop control, or is that a closed loop control action? I am asking about feed forward
Open loop,
control. Yes, tell me.
sir. Open loop, sir.
No, sir. Actually, I am giving you the example of bread toaster. Actually, bread toaster is a open loop control action because no feedback control is there. But feed forward control also a closed loop control. Why closed loop? Because it is measuring the disturbance. It is measuring the disturbance also. Okay. Uh, so that's why just apply common concept. In feedback control system, there is apply the measurement of process value, but they are not apply the process value, rather they are apply the disturbance. So they also measure the disturbance. By applying the disturbance, they also doing this. So whenever we go for the diagram, then you can understand. Look, this is also a closed loop control, but not feedback. Okay, so controller, look, in this case you can understand, and many where many high it is applied. This is process PROCSS process. This is disturbance. This is input, or you can say input, or you can say manipulated variable. Manipulated variable. Okay, this is controlled output. Output. You can see this is a closed loop control system. This is a feed forward control system. Because it is measuring the disturbance. Okay. And in case of your closed loop control action, you can see I am drawing just closed loop control action for your better convenience. That is also manipulated variable. Variable, or you may say this is input. This is comparator. This is called comparator or summer. Okay. This is actually, this is on off control, on off valve, on off. It may be valve or switch, anything, means it is a gateway. Okay. And this is your process. This is your output. Output is measured by this feedback. This is a sensor. Okay. This is a feedback. After few days, you can you study this sensor transducer also. This is a concept of controller. Okay, this is also a closed loop. This is also a closed loop. Okay, and guys, if you have any question, you may ask me. And I want to giving you, because time is very less. So please draw this picture, because if the question is coming, you have to write down this. This is feedback. Feedback. This is feed forward. Here is no disturbance. Uh, no disturbance is considered over here. But if this disturbance is coming, this controller may not be reach the set point value. Okay, so I'm giving you the another example, very short of time is here.
Sir,
Yes, yes.
which one is more efficient, sir?
Actually, efficiency is measured as per the reference frame where it is required. If you have the disturbance so many times, then your feedback controller system is less efficient. Okay, then you have to apply feed forward control system. But if no disturbance is there, means disturbance means your process is not varying. Say 100 liter you applied, so after some time 100 liter is there, no any things is changed, then this is feedback control system is very much efficient. So this is depends on the reference frame where you are applying. Just like your say your biscuit factory, your coffee machine, you are applying, so, someone coming that you are applying 5 cup of coffee machine, but after few times, one is telling that no, I also join your party, so you have to apply more, 1 cup, so 6 cup. So first time you just get as you can see your automatic coffee machine for home purpose. I'm saying home purpose. Say you put some database, the 5 cup of coffee 5 cup of coffee, okay, and you are applying say 10 second, some temperature is say this is T1 temperature. After 2 second passing, one another public is coming. He is saying, I want to join with your coffee. So you have to add some 1 cup of coffee. So it is a disturbance. So what will happen? You have to apply some more temperature. Say if you apply the T1 second, it will uh, not become perfect. So you have to apply, either your temperature should be increased, either time should be added more. Okay, then it will reach 100 degrees centigrade. But in your feedback control, you can't say that okay, 5 cup coffee is ready, then you are wait, then we apply one. But in this case, if you have an idea, then you can apply. But in the feedback control system, whenever it is, if disturbance is coming, first it is going for the 5 cup of coffee, it is whenever after 2 seconds it will reach 80 degrees centigrade. But if you apply 1 cup of water, then it will decrease 60 degrees centigrade. It will take more time. So you never reach after 10 seconds. So in this case, 10 second is vital, because after 10 seconds they have no time. They will go out. Okay. I think you can understand.
Yes, sir. Clear, sir.
Clear? Okay. मतलब if I say आफ्टर, बिकॉज 5 आदमी आया है, आपका 5 फ्रेंड आया है, तो 10 सेकेंड आपको टाइम ले सकते हैं। लेकिन अगर 6 आदमी आ गया, तब उसको नहीं बोल पाएंगे कि 10 सेकेंड हो जाने के बाद आपको 5 आदमी पियेंगे कॉफी, उसके बाद फिर हम आपको थोड़ा 2 सेकेंड बाद आपको 6% को दे देंगे, क्योंकि पहले 5 आदमी खाएंगे, उसके बाद 1 आदमी खाएंगे, नहीं होगा, और उसके पास 10 सेकेंड ही है। बट इधर देखो, इधर फीडबैक कंट्रोल सिस्टम में क्या होता है, ये कभी 10 सेकेंड, पहले 5 कप कॉफी दिए है 10 सेकेंड के लिए, लेकिन जैसे आप 1 कप कॉफी के लिए फिर वाटर डालें, उसमें क्या होगा, और 10 सेकेंड नहीं लेगा, से वो 12 सेकेंड लेंगे। I am saying about only this 12 second, 10 second. This is normal home purpose. So this is not important to you. But if it is applied for your process control, if it is applied in your industrial aspect, then 10 second or something, some second or some temperature is very vital, because whenever we go for a chemical process, if temperature is very as they differ, then it will decompose or something happens. So just don't take it as a coffee maker for your home. Just take it for your industrial purpose. Then every second, every temperature, every degree is vital. Okay. So just like your distillation process of ethyl alcohol and methyl alcohol. For the methyl alcohol, this is 72 degrees centigrade, but the ethyl alcohol, this is 62 degrees centigrade. So you can see normally your temperature value, this is very close to here, 72 degree and 62 degree. If you apply some normal mercury thermometer, it is very difficult to control it, because 62 and 72 is very close over this process. Okay, say ethyl alcohol is distilled from methyl alcohol. Okay, guys, I think you can understand now. I am going to close over here. If you have any question, you may ask to. Okay, thank you. Have a nice day.